Okay, on this problem, we're asked to find the critical numbers and determine whether they are maxima, minima, or neither. And this is going to be a fun problem because there's probably going to be infinitely many of these places if you think about the cosine function, how it looks. Oh, h prime is what we need to find first. The derivative of the cosine is negative sine, but you've got a chain rule here, so it's going to be negative sine 2 theta times 2. So this will be negative 4 because it times that 2 sine 2 theta minus, here we'll just have 4 sine 4 theta. And we want to see where that is equal to 0. And don't do anything crazy like think you can factor a sine 2 theta out of that. Probably the best way, you could take negative 4 out, and so then you're just thinking about where sine 2 theta plus sine 4 theta is equal to 0. And then you don't have to worry about that negative 4 because it just kind of falls out when you divide through. Now, sine 2 theta, you can use the double angle formula. That's 2 sine theta cosine theta. And then you can do like a double angle formula for the sine of 4 theta. You can think of this as the sine of 2 times 2 theta. So the double angle formula there would be sine, this will be 2 sine 2 theta cosine 2 theta. All right, and then this 2 sine 2 theta, that you can write as 2 sine theta cosine theta plus 2 sine theta, and that'll be 4 then. 4 sine theta cosine theta, because we can't apply the double angle formula there, which is that it's 2 sine theta cosine theta times that 2. But then you still have that cosine 2 theta there. But the good news is that this is getting a little bit better. If you believe me, I can factor 2 sine theta cosine theta out, and then I'll just get 1 plus 2 cosine 2 theta equals 0. So now this is 2 sine theta cosine theta equals 0, or 1 plus 2 cosine 2 theta equals 0. Well, this is really saying this is going to be true when the sine of theta equals 0 or when the cosine of theta equals 0. And this is going to be true when the cosine of 2 theta is equal to negative 1/2, right? Which is true when 2 theta equals, let's see, negative 1/2 is going to be in the second quadrant at 2 pi over 3 plus 2k pi. And then also in the third quadrant, which is 4 pi over 3 plus 2k pi. And sine of theta equals 0 at 0 plus 2k pi, and then also at pi. So really, at multiples of pi, the sine of theta is equal to 0. So you could say k pi. And then this is multiples of pi over 2. Actually, if you just write it as k pi over 2, you're going to get all the k pi plus all the odd multiples, because that's at every 90 degrees. So this happens. This is true at k pi over 2, and then this is going to be true if you divide everything by 2 here. That's going to be, when you divide this by 2, you're going to get pi over 6 plus k pi, and then 4 pi over, or so 2 pi over, let's see, divide by 2, so 2 pi over 3 plus k pi. So those are all your critical numbers, and so you're going to want to kind of see what's happening there. I'm going to run out of time on this video, so I'll have to continue to look at this in a second video. But let's just imagine if k equals 1. And so our critical numbers, or actually, let's say k equals 0. So we'll have critical numbers at 0, pi over 6, and 2 pi over 3. And let's see what happens there. And I'm going to start another video because this one I ran out of time.